Hello student, today we will learn about angle of contact and capillarity. For that we take two liquids, one is water and another is mercury. If you think the shape of meniscus, for water it is concave shape, this is concave shape meniscus, and the meniscus of mercury is convex in shape. Why the shape of meniscus is concave or convex? For that purpose, let us say here we have the boundary of the container and liquid is filled inside this. For reference, we take a liquid molecule here. This liquid molecule is surrounded by the other molecules nearby. And they will produce a cohesive force like this one. This is cohesive force. And if we say the container of wall is also having a molecule, the force between the liquid molecule and the container molecule will be adhesive. And if it is adhesive, then this liquid molecule is attracted by the solid molecule, and this is adhesive force. The resultant of these cohesive and the adhesive force may be derived with the help of a parallelogram. So this is the force, net force acting on this liquid molecule. The liquid molecule is represented here, and this is net force. This net force is the surface tension. That is, net force applying per unit length is surface tension. So this is the direction of tension. Whereas in second case, in case of mercury, let us say here is the wall, and this is molecule of wall, and here is the liquid. And at this time, the liquid is mercury. The mercury molecule are like this one, and they will produce cohesive force. This is cohesive force. And the force between the mercury molecule and the solid container molecule is the force, adhesive force. And if this force is, adhesive force is more than the cohesive force, then the net force will act in this direction. This is the resultant force. So the surface tension will be in this direction to the molecule as a reactive nature. So this is surface tension, that is force acting per unit length on this liquid molecule. Because of that, the liquid will be convex shape. And in this case, the liquid will be concave shape. The surface tension is tangential to the liquid surface. Because of the cohesive and adhesive force, we have two different nature of meniscus. One is concave, other is convex. Now, the angle between the tangent of the liquid, this is liquid, and this one is the tangent. This is the tangent of the liquid surface. At the contact and the tangent of the solid surface. Now, what is solid surface? Here is the surface of container. So this is tangent of the solid surface. The angle between these two tangent, the liquid tangent and the solid tangent inside the liquid, is called angle of contact. Here, this is liquid tangent, liquid surface tangent, and this is the solid surface tangent. And the angle between these two tangent inside the liquid, this angle is called angle of contact. The angle of contact will depend on the nature of container and the liquid. So the pair of the material will define the angle of contact. For example, for mercury and glass, the angle of contact is 130 degree to 140 degree depending on different type of glass. So the angle is obtuse angle. This angle is obtuse angle. It is 130 to 140 degree. Whereas in case of water and glass, the angle is 8 degree. It is acute angle. So if angle is acute, the liquid will wet the wall of container. The liquid will wet the wall of container. The water will wet glass. If we change it by kerosene, then kerosene will also wet the glass. But if angle is more than 90 degree, that is obtuse angle. In case of mercury and glass, if angle of contact is obtuse, the liquid will not wet the container. Now, next point is capillarity. What is capillarity? A tube of very fine bore is called capillary tube. A tube having a very fine bore tube, that is called capillary. If we say this is a tube, this tube is having a bore and this bore is very fine. It means the radius is very small. Very small. Then this tube is called capillary. And when this capillary tube is dipped in a liquid, if it dip in a liquid, then there is a rise of liquid inside the capillary. The liquid will rise. It will move upward. And in just like as it is it is condition of water, and it is plastic tube, that is, it is a very fine plastic tube, then the water will reage in this tube. But if we say we have liquid as mercury, and the liquid and the capillary is dipped inside there, then the mercury will fall down inside the liquid. This is mercury here, this is mercury here, and the liquid mercury is fall down. The rays of liquid or falling of the liquid inside the capillary tube is called capillarity. The phenomena of rise or fall of a liquid in a capillary tube is called capillarity. Now let us find out how much liquid will rise or fall down inside the capillary. The expression for capillary rise is also known as ascent formula. As we know, the liquid will rise or fall inside the capillary. So we have to derive the formula for this rise or fall. Here is the liquid, and this liquid is inside this container, and here is the capillary. This is capillary. The radius of capillary is r, and the height of liquid rise is h. The height of liquid rise is h, this one. The density of liquid is rho. Rho is the density. Theta is the angle of contact. The angle of contact is the tangent on the surface of liquid and the tangent of the solid surface of container. The angle between them is called angle of contact, and it is theta. The surface tension of liquid is acting tangentially downward. This is acting tangentially downward. And the reaction of this surface tension is R, and it is equal to T. So the reaction on this, because of the surface tension, is T. And the reaction R is equal to T, the surface tension. Now, when the capillary tube is dipped in the liquid rises up in the capillary tube due to combined effect of the reaction of the surface tension and adhesive force. The liquid rises up in the tube so such a height that the vertical component of the reaction of the surface tension balance the weight of the liquid which rise in the tube. Now, if I say this is the liquid surface, this is the liquid surface which join the container. Here is the shape of meniscus. The T is the surface tension. then reaction of the surface tension is equal to also T. And the angle of contact is theta. So this angle is also theta, vertically opposite angle. So here will be the component that is T cos theta. And the other component of this one, reactive tension, is T sine theta. Similarly, the liquid molecule may be taken as just opposite side. Here, in figure it is B. The surface tension reaction part is T, and the component will be T cos theta and T sine theta. This T sine theta component will cancel the effect of each other because they are opposite to each other. Only T cos theta component of the surface tension will raise the liquid upside. The T cos theta component will raise the liquid upside. T cos theta, T cos theta. All are T cos theta. For each and every molecule on the surface. So this T cos theta component will act on the circular surface, which is joining the liquid container. So the net upward force, because of this reactive part, and it is equal to T, will be on the circular loop, because it is T cos theta, T cos theta, T cos theta, and so on. So it is T cos theta multiplied by 2 pi r, the circumference of the circle. So net upward force will be T cos theta into 2 pi r. Net upward force will be T cos theta, that is part of the surface tension, into length is 2 pi r. Surface tension into length is force. But the liquid which raised up, because of this T cos theta into 2 pi r force, the liquid will raise, but same time the weight will be vertically downward of this liquid which is raised up. So downward force will be m into g. Mass is equal to mass upon volume, you know, is density. So mass is equal to volume into density. So it is V rho G. The volume of the liquid. Now the volume of the liquid, we will take two different parts here. One of the volume of the liquid of this side, this cylinder. This cylinder. And this is volume of cylinder is pi r square h into rho g. But that some liquid is raised in the shape of meniscus, that is concave shape. We also have to take the consideration of this liquid. this liquid. The volume of the liquid, how we find here? The volume of the liquid will be volume of this cylinder, this upward cylinder, this cylinder, that is pi r square h. H is the radius of this meniscus. So this is the volume of the cylinder. But we have to subtract the hemispherical part, which is the air. So the volume of the hemisphere is 2 by 3 pi r cube. So the liquid volume under the meniscus will be 1 by 3 pi r cube if we subtract this one. So the net weight, if we consider the meniscus as well, then it will be the total volume of the liquid which raised. It is pi r square h here, red part, and 1 by 3 pi r cube, that is the green part. So the net volume of the liquid is pi r square h plus r by 3. So the net downward force will be volume pi r square h plus r by 3 into rho g. This is net weight of the liquid which actually raised inside the capillary. And this is overcome by the upward force, that is T cos theta into 2 pi r. So we equate these two forces for equilibrium. So T cos theta into 2 pi r is equal to pi r square h plus r by 3 into rho g. Hence, we may find out the height of the liquid column which is raised. So this is the formula for liquid raise inside the capillary. This is also known as ascent formula. But the radius is very, very small. Radius is very, very small than the liquid rise, as it is capillary, and capillary is fine pore tube. So the ascent formula will be nearly equal to 2t cos theta upon r rho g. We neglect this r by 3 part because it is very, very small part. If we consider the liquid and the inside the container makes 0 degree angle of contact. It means the meniscus is plane meniscus. Then cos theta is equal to 1 because theta is 0. Then we may write here cos 0 is equal to 1. So we will get the liquid height is 2t by r rho g. And for liquid wet the tube means just like as water, where the angle of contact is acute, the h will be positive because cos theta will be positive. 0 to 90 degree, the cos theta will be positive. So h will be positive. But if theta is more than 90 degree, in case of mercury, theta is more than 90 degree, it means it is in second quadrant, and in second quadrant cos theta is negative. Cos theta is negative, so H will be negative. So liquid does not wet the liquid tube and it will fall inside the tube. So the rise or fall of the liquid is the capillarity, and the ascent formula, that is how much it will be raised, will be H is equal to 2T cos theta upon RO G.